Okay, the final lesson in this chapter looks at slope as being a rate of change. And we've looked at this, I know you've looked at this in physics class. So if we look at the first part, the graph shown represents the distance traveled by a car as a linear function of time. So it says complete the following to calculate the slope. If we use our slope formula, the change in the y coordinates divided by the change in the x coordinates. 120 minus 40. And then 3 minus 1. So what's 120 minus 40? 3 minus 1?
2.
What's 80 divided by 2? What units were represented on the top? 120 what? Kilometers. And what units were represented by the x's? Hours. So what I actually get here is 40 kilometers per hour. It's the change in distance given the amount of time. So in this case, the distance is doing what? Increasing or decreasing? Increasing at a rate of 40 kilometers per hour. Okay, if I look at the oven, what would be the slope of this line? So what would be the difference in my y values?
800.
350 minus 50, which equals 300. And what would I subtract my x values? What would be my x values? 5 minus 0. Oops, not 50. And 5 minus 0 is? 5. And what's 300 divided by 5? 60. Now, 300 or 350 and 50 represented my temperature. That was degrees Fahrenheit. And my denominator, which was represented by my x-coordinates, was time in minutes. So this is a change of 60 degrees Fahrenheit per minute, a rate of change. So if we complete the statement, the temperature is increasing at a rate of 60 degrees Fahrenheit per minute. Okay, let's look at the next one. Graph shown represents the amount of gas in a car as a function of the distance traveled. So when I calculate the slope, what would I write on the top? Which one? Not 120 minus 50. The y coordinates. 50 minus 40 over 20 minus 120. Okay, what's 50 minus 40? And what is 20 minus 120? Negative 100. Which gives me negative 1/10, or 1 over 10 as a fraction, or negative 0.1 as a decimal. Okay. What did the 1 represent? What did the y values represent? Number of liters of fuel. And what did the x's represent? Distance. Okay, so the units used to represent this change would be number of liters per kilometer, not distance. So maybe liters per kilometer. Okay, the amount of fuel in the tank is doing what? Decreasing. So the rate of change, actually we'll skip that one. Or sorry, no, the rate of change would be negative 1/10 liters per kilometer. That's the rate of change. But if I fill in the blanks for the second one, the amount of fuel is decreasing at a rate of, I would only use 1/10. I wouldn't put the negative because the negative is implied with the word decreasing. So it's decreasing at a rate of 1/10 per kilometer. So if I was to determine the equation of this line, that rate of change is the slope. So I have my slope value. N will equal negative, I'm going to leave it as a decimal, D plus B. Do I know what the y-intercept is? Can I see where it crosses the y-axis? I can see it, but I don't know what that value is. But I do have other points on the graph. I am given one of these 2 points. So I can use that in my equation. I can take this point of 20 and 50, and I can substitute it in. 50 is the number of liters, and 20 is the distance. So if I take 20 and I multiply it by negative 1/10, what do I get? Negative 2. And then to get b by itself, what do I do with that negative 2? Move it to the left, and it will become positive. So then b would equal 52. So then my equation I can write has n equals negative 0.1 d plus 52. Or I could write it as n equals negative 1/10 d plus 52. So I could use the decimal because it's a nice terminating decimal to use, or I could leave it in its fraction form. So this connects rate of change with being able to do an equation, kind of giving you a real life example. Tyrone is paid a base salary a week plus commission for selling electrical appliances. Last week, his sales totaled $3,500 and he earned $620 from that. This week, he earned $680 for sales of $4,250. So if I went to plot this, the sales go along the horizontal, the earnings is the vertical. So my first point, his sales of $3,500 and earnings of $620. So that means that my x-coordinate would be 3,500 and my y-coordinate would be 620. And then in the second week, it would be 4,250 and 680. So further to the right and a little bit higher. 4,250 and 680. There's my straight line. So calculate the slope for of that line for me. Okay, so if we calculate the slope, the difference, so 680 minus 620 over 4,250 minus 3,500. And what do you get?
60 over 750.
Okay, and what would that be as a decimal?
12.5.
Other way around. You divided backwards. Okay? What does this mean?
How much earnings he gets per sale.
That's the earnings per sale. So what that means is he earns, how much money is this? 8 cents. So earnings of 8 cents from every, how much does he have to sell to earn 8 cents? $1. From every dollar sold. So what's his rate of commission? 8 cents per dollar. So what's that as rate? 8%. So what is his base salary? How much does he get paid no matter what? So what that means is he's got his weekly earnings equals 8% of his sales plus this base. There's my y equals mx plus b. So I have a sample. I can tell you that he earns $620 when he sells $3,500 worth of stuff. And I can solve that equation to find out what B equals. So if I take 8% of 3,500, what do I get?
280.
So I get 620 equals 280 plus B. So if I take the 280 off both sides, what does B equal? 340. So the base salary is $340 per week. That's how much he gets paid no matter what he sells. Where would I find this point on the graph? Or could I find the point 340 on the graph? It would be my y-intercept. Because that represents how much he makes when he sells nothing. Okay, so it is the y-intercept. Or in this case, the e-intercept, because it's the e-axis. So if I rewrote my equation, E equals ms plus b, what is m? The slope, which is 0.08. And what is b?
340.
So it's the amount of money that he gets for no sales. So 2 weeks ago, Tyrone earned $486. Figure out how much his sales were that week for me, please. Okay, how did you figure that out?
All I did was subtract his base income from 486, or his, makes for sure, his base salary. And then I just divide that by 0.
So I take off the 340 and that leaves me with 146.
Divide that by.
Divide both sides by 0.08. And how much money did you get again?
1,800.
This is how people who earn commission normally, a lot of them get paid. They get a base salary and then they get a percentage of their sales.
That's how car dealership is.
Yeah. And some places go on straight commission. So if you sell nothing, you volunteered your time that day. John's taking part in a long distance race. After 3 hours, he traveled 270 kilometers, and 6 hours, he traveled 630 kilometers. On a grid, plot the ordered pairs to represent this information. So you're going to need to come up with a scale that makes sense, and you're going to my distance in kilometers would be my vertical. So 3 hours traveled 270 kilometers. So somewhere around here. And then after 6 hours, 630 kilometers. Calculate the slope of the line segment joining these two ordered pairs. So that's joining these 2 points. So I'm going to give you a moment. I want you to calculate the slope of that line.
And this one's if she pays 33%. So if she can spend anywhere from $413.10
$360. So 360 divided by 3 is
120.
So the slope of the line segment represents a change in time. The distance divided by the time. Distance, kilometers, time, hours. So this 120 is the speed of the car. So he was driving 120 kilometers an hour from hour 3 to hour 6. If I plot the point 0 and 0, at time 0 he's traveled 0 kilometers. And if I join that to my first point on the graph, does this form a straight line all the way through? Are these two line segments straight? No. And I can see that. If I take this line and I extend it through that point, they're not straight. So from point 0 to this end point, it's not a consistent, it's not linear all the way through. It's 2 pieces. Okay? Find the slope of that part in blue. And tell me what you get when you find the slope. $90 what? This is speed, so this would be 90 kilometers per hour. Now, let's say you were just given the graph. How could you state which slope was greater, or which speed, I guess, in the graph? How could you tell me that the speed from in blue is going to be less than the speed in green? Less of an increase, which we call slope. The slopes are different. So by looking at the grid and without doing any calculations, how can we tell that the average speed during the first 3 hours was less than the next 3 hours? Because the slope of the line is less in the first 3. So it just gives you some applications as to where we can actually use linear equations. So the questions for this section, 2, 3, 6, 9, and 10. Full, because your test tomorrow talks about slope.
Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him and he'll teach us some important aspects of slope. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. But now he can look forward to the downhill. On the way down the mountain, he says, nice, negative. Nice, negative. And now, after the downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead, and all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the Adventure of Slope Dude. Remember always what he said during his ski trip. Up the hill or up the slope, he said, puff, puff, positive. On his downhill run, he said, nice, negative. On the long, flat part of the course, he said, this is zero fun. And finally, when he went over the vertical cliff and went straight down, he yelled the worst curse word of math and algebra. Undefined! The uphill is a slope with a positive number, the downhill is a slope with a negative number, the flat part is a slope of zero, and the straight up and down or vertical part is undefined. This has been the Adventure of Slope Dude.